Hello, my name is Ardi and we are going to solve this problem. Here, apply nodal analysis to solve for Vx in the circuit of figure 3.56. Okay, we have the key here. We need to do nodal analysis and let's break it down step by step. Okay, how to do nodal analysis? Let's do it step by step then. Nodal analysis. Okay, the first step that we need to do is to label all the nodes. Label all the nodes. And what is the nodes here? Maybe let's use this bottommost node here as our ground. So the voltage here will be 0. So some people says that this is reference node, but that is the same as the ground. Good. And then we also have another nodes here. Going from here to this, all of this is a single node, right? Because it is connected by a single cable. So we will have this node here. Let's name this node as node A. Okay, we already have labeled all the nodes here, which is node A and the ground here. Okay, now what can we do from here? Let's do the second step, which is assuming the directions of the current. So we need to assume all the current's direction. Okay, how to do that? Okay, we can just assume that the current that goes from the current source here is just going like the arrows here. So this will going up and this will going down. And for the one that is unknown, we can just assume arbitrarily. So I assume this is going down and this one is going down here. And I think we have done all the step for step number 2, which is assume all the currents direction. And then we move on to the third step, which is to do KCL for each nodes. Okay. What does KCL say? KCL said that the sum of the currents that goes in is equal to the sum of the currents that goes out. Okay, let's do KCL at node A. So as I said, that is sum of the current that goes in will equal to the sum of the current that goes out. Good. Okay, let's see here. Where is the current that goes in? And I think this one is the one that goes in. And all the others are going out. So this 1, 2, 3 are going out. So one current goes in and 3 currents goes out. So let's write it one by one. So we know that this is 2 ampere here. So we will have 2 on the left hand side. And that is the only current that goes in. So let's put the equal sign because all the other currents is going out. This one here is going out, but we don't know the value yet. But we have this node here, node A. So the voltage here will be VA. This is where the current comes from, right? This node here. And where the current goes to, it goes to the reference node. So we'll have minus 0. But this is a voltage, we need current. Remember the Ohm's law, for getting current, we need to divide voltage by resistance. And the resistance between them is 10, right? So we'll have 10 here. Good. And then what is this one here? We will have the same. So we'll have VA as the current comes from. So this node A is where the current comes from. And then minus 0. 0 is where the currents goes to. So we'll have divided by 20. Minus 0 divided by 20. 20 is the resistance between them. And then one more current here, but this is a dependent current source. And the value is this number here, 0.2 Vx. So we'll have 0.2 Vx. 0.2 Vx. But what is Vx then? Okay, Vx is this one. And what is Vx? Vx is the difference between this one, the positive terminal, which is node A here, and the negative terminal here, which is this one here, because it's connected via this cable, right? So we will have this equation here. Note that Vx is the difference between the voltage in these nodes. Okay, so that is VA. And then minus this node here, right? Because the negative terminal is connected to the ground, so we'll have minus 0. Therefore, Vx is equal to VA. Good. Okay, now let's plug that into this equation. So we can change this Vx with VA, right? Because that is the same things according to this equation here. Good. Okay, now what can we do? I think we can multiply both sides here by 20, right? To cancel out this one, to cancel out this one, and also to cancel out the decimal value here. So we will have 40 on the left hand side, and that will equal to 10 and 20 will cancel into 2, but 2 multiplied by VA minus 0. We will have 2 VA from this term here. And then this one, 20 and 20 will cancel each other, so we will have VA. Good. And then we will have 20 multiplied by 0.2. That will be 4, right? We will have 4 VA. Good. And now we will have 7 VA is equal to 40. Okay, now we will have VA is equal to 40 divided by 7. Okay, and we can just plug that into calculator. What is it? 40 divided by 7. So we'll have 5.714. Okay, 5.714. And the unit will be in volt. Okay, that is our VA, but then we need to answer the question, which is the final step. Answer the question. Okay, what is the question asking us about Vx? So what is Vx? Vx is equal to VA, right? We already analyzed that. So we will have Vx here is equal to this number here, 5.714. And the unit will be in volt. And this is the final answer for this problem. Apply nodal analysis to solve for Vx. So here is the value of Vx. Hopefully I did not make any mistakes in my calculation. Thank you for watching. See you in the next video. Bye bye.